Thank you for coming today, Mike. Maybe you can give a short introduction of your company and activities.
Sure, no problem. Yeah, so my name is Mike Cooke and I've been in the industry for just over 31 years. Started off in Australia, as you can tell by my accent. And I worked for Outotec for 23 years. Then after that with Paterson Cooke. And Paterson Cooke's, they're a consulting company and they're an engineering company who specialise in slurry and transportation systems and rheology and also backfill systems. And Mynext is like a product company that sells products and does upgrades and greenfields and brownfields sort of applications.
You talked about products, but what kind of products do you sell as Mynext?
So the majority of thickener upgrades require a new feed system, and the reason being is progressively over time the throughput changes or even the characteristics of the ore changes. The components that were originally designed become too small. We upgrade the feed system and put in a better feed dilution system, which is critical, and we make sure that the feed system is dispersing equally throughout the whole tank, which is another issue we seem to find in many applications where the thickener is short-circuiting.
So is that the worst possible design of a thickener?
Worst scenario in a thickener, which we often see, is the feed, because the feed's changed over time, the feed's coming at a higher velocity than the feed pipe is designed for, or is desired optimized sort of velocity. It's got air entrained in there, and then it hits the feed well, and the feed well is incorrectly sized. If you have an open bottom feed well, the material comes in, short circuits, and drops straight into the underflow cone. So it never gets distributed out to the thickener where it compacts and it's raked, dewatered, settles, compressed, and then slowly raked to the center. It's actually like a core. So the core just falls straight down from the feed well vertically, straight into the underflow cone. So your material coming in is dropping straight through, no retention time. That's what we call short circuiting. And
so there's actually not a thickener is probably called a thickener because you're thickening the sludge. But in this case, you're just moving it like a pipe towards the next phase.
Correct. And you find materials floating around and going up inside the thickener and then progressively settling or going to the overflow. So you get a dirty overflow, poor underflow density, and the rake mechanism then has to move all the material from one side of the thickener and spread it around the floor. And that's not the intention of the rake mechanism. The rake mechanism should be sweeping the floor evenly. It should be dewatering the settled bed, and it should be moving the settled material towards the underflow cone. So part of the problem from the segregation or short circuiting is you get a lot of the coarse material that causes a beach. And when it causes a beach on one side, you get a lot of torque spikes. So we often see thickeners with torque spikes every rotation of the rake arms, very dilute underflow, and then dirty overflow. So
the whole process of thickening is not even actually happening.
No, it's very, very inefficient. Yeah, you might as well just have an inline flocculant system. So injection into a pipe, because the density coming out the bottom is so so fluidized, because it's not compressed or raked or anything else.
So is that what you want to prevent as a mineral processing plant, or as
well? Yeah, it kind of stabilizes, or you need some sort of stable control, or and if you get to a steady state in the plant, the last thing you need is a thickener that's erratic as well. So the idea is to try and get some sort of normality in the thickener, and the best way to control that is to have where it begins. It's great having good instrumentation, but bed levels don't measure where the bed is. They just measure the height of the bed in one position. So it's very difficult. So, what you see on a bed level might represent the total area, but it's not representing the full thickener in different areas.
When you have the good design of having a good bed mass, a good level of the solids, do you also want to have a certain height of the bed mass and a certain height of the interface level? Is that also a control parameter?
Definitely, yeah. So the bed mass, obviously, you need to have the best bed mass as high as possible and the bed level as high as possible. But the bed level, you want the surface, the interface level, where the supernatant and the settling material meets the interface. You need that away from the launder, because you don't want to have a slight upset and then the solids reports to the launder. So you need a certain distance between the interface level and the launder. And then you need a certain bed mass to gain the compression, the retention that you need to get the obviously the optimal underflow density. Those parameters are determined in commissioning. And it's not just commissioning, it's in operation. So the initial parameters are put into the system and then they're adjusted by the operators over time. And it takes normally takes like up to 6 weeks to get that when the plant's in that sort of steady state. And then the thickener's settled in, and then the parameters are then adjusted by the operator slowly.
So first of all, you want to have a good design, and then you use the measuring instruments just in case, I mean, if something changes or something is not the way you want it.
Correct.
And then you're able to control it. But it starts with a good design.
Correct, yeah.